This is a brief intro to nucleophilic substitution, and a nucleophile was just a species that is attracted to a positive species, such as a partial positive carbon and a haloalkane. And the nucleophile will attack positively charged species like the partially positive carbon and the haloalkane, like I said, and in the process, it will make a bond with that partially positive species and kick off what is called a leaving group. And the result is the R group bonded to the nucleophile as well as a lone leaving group. And to clarify, the leaving group in our example is the halogen that used to be bonded to the haloalkane. It will be kicked off once the nucleophile attacks and makes that new bond. So in this example, the hydroxide ion acts as a nucleophile, so the positively seeking species, and it will attack the partial positive carbon on this haloalkane. As a result, the R group, or CH3, bonded to the nucleophile, and the leaving group, chlorine, was kicked off. Here is an example where another halogen, iodine, will actually act as a nucleophile, so iodine will attack the partially positive carbon and the electrons will be kicked to bromine and bromine will leave. The nucleophile iodine replaced the leaving group and formed a bond with that carbon, and bromine, the leaving group, is now by itself. Some leaving groups are quote-unquote better than others. From last video we talked about trends in atomic radius, and we know that fluorine has the smallest radius, trending up to iodine with the largest atomic radius. Using the same logic as last video, fluorine has the smallest atomic radius of the halogens, so the bond between hydrogen and fluorine will be the shortest out of all the halogens bonded to hydrogen, with iodine and hydrogen making the longest bond. Because HF has a short bond, it is also a strong bond, so it doesn't want to give up hydrogen, so it's a weak acid. HI has a long bond, so it's a weak bond, so it'll give up hydrogen easily, so it can be classified as a strong acid. Therefore, the trend in acid strength goes with HF, hydrofluoric acid, as being the weakest acid because it holds on to hydrogen the strongest, and HI being the strongest acid because it holds on to hydrogen the weakest. We can also think of this in another way. Fluorine forms the strongest bond with hydrogen, so the conjugate base fluoride is most unhappy or unstable without hydrogen, while iodine forms the weakest bond with hydrogen, so its conjugate base iodide is most stable by itself. So the best leaving groups are weak bases that are most stable by themselves. Looking at electron-to-electron repulsion, fluoride is small, so all the repulsive electrons are squished together, unlike an iodide where the larger atom provides more space for the electrons to move around. Therefore, fluoride is stressed and unstable, while iodide is more able to be by itself and more stable. So iodide is the best leaving group. Now looking at nucleophiles, remember, nucleophiles are species that seek out positive charge. Because of this, when comparing two nucleophiles, the one with a negative charge will be the better nucleophile compared to one that only has a lone pair of electrons that can do the nucleophilic attack. So for example, in this case, the negatively charged hydroxide ion will be the better nucleophile compared to the not charged water molecule with two lone pairs of electrons that can do the attack. And if these two were paired up, the hydroxide would attack much more vigorously than the water would. That's why I put an exclamation point by the hydroxide and sleeping symbols by the water. So what if they are both charged? Unlike with leaving groups, the species that is more unstable is actually the better nucleophile. This is because it's going to want to form a bond more in order to not be by itself. We know that hydroxide is a weaker base than H2N, therefore I assigned it a neutral face relative to the stressed out H2N that does not want to be by itself, because hydroxide wants to form a bond less than H2N does, so H2N is a better nucleophile.